Hello everyone, welcome to Algebra 1 with Miss Betsy. Today we are starting to learn how to factor polynomials, a process that is just integral to the study of algebra, and I think one that you'll find to be a nice enjoyable change from just straight arithmetic. The text that I'm using is Algebra 1 for Christian Schools. I'm published by Bob Jones University Press. This is the second edition. You can use any edition that they have as long as you are following the same topic, and it doesn't even matter if you use a BJU Press book or not. If you want to learn how to factor common monomials, this video will be helpful for you. So let's pray, see what our lame joke is, and get started for today. Father, I thank you for all that you do for us and for all that you are to us. I thank you that you have given us a mind and the ability to think and to reason. Help us to apply that ability to the study before us today. In Jesus' name, amen. Lame joke for today. This is such a little boy thing. And I'm a teenager boy and an adult boy, I think. What did the boy say when he threw a slug across the room? Well, that boy said, "My, how slime does fly." Factoring common monomials. And this is a process that we've already been practicing just when we're prime factoring numbers or reducing fractions. We learned that a GCF, if we have, let me see, 60 divided by 5 times 12 times 7, making this one up, divided by 105, and we wanted to reduce that to lowest terms following the procedure of factoring in, rewriting each one of the numerator and the denominator as a product of prime factors. We would prime factor 60, and we would have that 60 can be written as a product of prime factors by saying 2 squared times 3 times 5. So 60 was equal to 2 squared times 3 times 5. And then we would also want to prime factor 105. And when we did that, we would have 105, let's see, how do I want to do this? 5 times 21, 3 times 7. And we've prime factored 105, and we see that writing 105 as a product of primes is 3 times 7 times 3 times 5 times 7. And then if we wanted to figure out what our greatest common factor was between 60 and 105, we look at the factors that we have in common. We have a factor of 3 and a factor of 5 in common. 3 times 5 is 15. And 15 then becomes our greatest common factor, which allows us to simplify 60 over 105 into 4/7. Okay. Now obviously I'm not going through reteaching how to prime factor and how to find the greatest common factor, but a common monomial factor is really nothing more than the greatest common factor. When we dealt with the GCF right here, we're only dealing with numbers. We're not dealing with variables at all. When you when you move to where you have an algebraic expression that has variables in it, then all the greatest common factor, all the common monomial factor, it's a monomial that is a factor of all of the terms in a polynomial. So this is the common monomial factor, which I'm not going to write out. But the common monomial factor, let me go ahead and write this because you really need to understand what it is. It is a monomial that is a factor of all the terms of a polynomial. This is what the common monomial factor is. What was our GCF? It was just a number that was a factor of a collection of different numbers. We just showed we had 60, we had 105, and let's go ahead and add in here 45. 15 was the greatest common factor between 60 and 105. 15 is also a factor of 45. Our greatest common factor of all of these is 15 because 60 was 4 times 15, 105 was 7 times 15, and 45 is 3 times 15, and you can see here 15, 15, 15 that we have in common, and then we have a factor of 3, a factor of 7, and a factor of 4 left over, so our greatest common factor is 15. Our common monomial factor would be, let's just say that we have 60x squared, 105xy, and 45 xyz. So we have 3 terms together, but now instead of just having individual terms, let's make this a trinomial. Let's say that we have 60x squared plus 105xy plus 45xyz. We already know what our common factor is of those coefficients, don't we? We know that the common factor of 60 and 105 and 45 is 15. So we've already dealt with the coefficient of each of the 3 terms of this trinomial. Now, however, let's go ahead and look at the variable part. We have an x squared, we have an xy, and we have an xyz, and these are all factors. It's 60 times x squared, or 60 times x, 105 times x times y, 45 times x times y times z. So just like when you're comparing the common numerical factors to find the GCF, we're looking for common algebraic factors. We've got an x squared here, an x, and an x. So we have a common algebraic factor of x that shows up in every one of the terms of this trinomial. Now we have a y that shows up in 2 terms, but does that y show up in the first term of this trinomial? No, there's no y, so the y is not a part of the common monomial factor. And what about the z? The z only shows up in our 3rd term, so z is not common. This 15x right here is our greatest common monomial factor. It's easy to get your tongue twisted around. The greatest common factor, the GCF, they're typically talking simply with numbers. When they call it a common monomial factor, what they really mean is the greatest common factor of an algebraic expression, because your common monomial factor is going to include variables most of the time. But sometimes, let's just say that we had let's have this be a cubed. The greatest common factor of the coefficients here is still 15, right? But do we have a common variable factor? Do we have a variable in common? No, we've got a cubed, but we don't have an a cubed anyplace here. So the common monomial factor of a trinomial can still be simply the numerical part of it. All right? So now with that background, let's go ahead and look in your text and see the examples that they show us. Let's see. This says example 1, factor 8x squared minus 16. This is example 1. We are in section 9.1, page 364 of the second edition of Algebra 1. And our instructions here are to factor 8x squared minus 16. So what do we want to do? We want to factor each term into primes. Okay? The first term is 8x squared. So you know now that 8 is 2 cubed. If you don't, you can factor it out. 2 times 2 is 4 times 2 is 8. Now we want to factor 16. And you should also know that 16 is 2 to the 4th, written as a prime factor, product of primes only. There are no variables here. Now what we need to do is identify the greatest common factor in these. What's our greatest common factor? Our GCF here is simply 8 because there's no algebraic factor, no variable factor that they have in common. Now, what we're going to do is factor out the 8 from our binomial. So how do we factor that out? Now let's remember that, what are factors? Factors are the numbers, the quantities rather, that you multiply together to end up with a product. So, factor times factor is equal to product. An example here would be 2 times 3 is 6. The factors of 6 are 2 and 3. 2 times 3 is 6. Now, so you multiply to get a product, you factor to get, to undo this operation. Let me read what we have here. Multiplication begins with the factors and finds the product. Factoring is the opposite of multiplication, and it begins with the product and it finds the factors. So what we're learning to do is to find this common monomial factor in a polynomial. What we're doing is sort of applying the distributive property in reverse. We have 2 thought processes that we can use to do this. If I'm factoring out an 8 from 8x squared, what I'm really doing is dividing. What is 8x squared divided by 8? 8x squared divided by 8 is x squared. Now, what is a negative 16 divided by 8? Negative 16 divided by 8 is the negative 2. So we have x squared minus 2. And we have now factored out our common monomial factor from this binomial. Remember, I just said that this is like doing the distributive property in reverse. How are we going to check this? We're going to use the distributive property. What is 8 times x squared? 8 times x squared is 8x squared. What is 8 times a negative 2? It's a negative 16. So when we multiply back our common monomial factor against what we have remaining, we end up with our original problem. Now I said there's another way that you can think when you do this. I believe your book sort of calls this reverse thinking. We'll just talk it out. What did I say? What did we just show that our common factor was? Common monomial factor was an 8. So we're going to factor an 8 out, and we think 8 times what is going to give me x squared? Well, 8 times x squared gives me 8x squared. 8 times what is going to give me a negative 16? 8 times a negative 2 gives me a negative 16. So that's how we ended up with 8 times the quantity x squared minus 2. And again, this is very easy to check. 8 times x squared is 8x squared. 8 times a negative 2 is a negative 16, and you verified that you properly factored this binomial. Okay, let's go ahead and look at example number 2. Example 2 says factor 3x squared y, 3x squared y minus 27xy plus 9xy cubed. Now our greatest common monomial factor, they call it simply the common monomial factor, is going to be two parts here, if possible. There's going to be a common, typically a common constant factor, and there's typically a factor in common that involves a variable. So let's look at these coefficients first. We have 3, 27, and 9. And if you're not able to look at those three numbers and know that 3 is the common factor there, you need to go way back in your book, and I think it's 1.7, figure out how to do prime factoring. So 3 is the common factor of 3, 27, and 9. Now, let's look and see if we have a variable factor in common. We have x squared, x, and x. Our common factor in the x's is simply x. What about y? Do we have a variable of y that's in common? We have y to the first, y to the first, y cubed. So we have one factor of y in common. Our greatest common monomial factor, this is the word, common monomial factor. This is essential that you learn how to properly identify the common monomial factor, because that's the very first step in fully factoring a polynomial. We have 3xy as our factor. Everything that we have remaining is what goes inside these parentheses. Think of it two ways. Each term divided by the common monomial factor, or the common monomial factor times what will result in that term. First, I'm going to say, think out loud, 3x squared y divided by 3xy. What do I have remaining? I have a factor of x remaining. And we can check this by saying 3xy times x is 3x squared y. Now we're looking at negative 27xy. If I have negative 27xy divided by 3xy, what is that? It's a negative 9, isn't it? X minus 9. Now, what do I have? 3xy times a negative 9. I'm checking this back already. 3 times negative 9 is a negative 27. X times y times 1, there's xy. see what we're going to factor out of this last term, 3xy times what is equal to 9xy cubed. So let's check this back. 3xy times x is 3x squared y. 3xy times a negative 9 is negative 27xy. 3xy times a positive 3y, 3 times 3 is 9, x, y times y squared is y cubed. So this is what pulling out the common monomial factor is. You're doing the distributive property in reverse. Let's go ahead and look at example number 3 now and see what we end up with. For example 3, this says factor 14a cubed plus 21a. 14a cubed plus 21a. Now we're going to factor each term. What is 14a cubed? Well, 14a cubed factors into 2 times 7 times a squared. 21a is 3 times 7, 21a is 3 times 7 times a. So, what factors do those two numbers, or those two quantities, have in common? That's what's going to make up our common monomial factor. We don't have a factor of 2 in common, don't have a factor of 3 in common, but there is a factor of 7 in common, and there is one factor of a in common. So our common monomial factor is 7a. 7a goes outside the parentheses, and all of the remaining factors stay inside. Now let me show you this. If 7a is our common monomial factor, let's look up here. We've already used a 7 and an a. What's remaining in there? The 2 and 2 more factors of a. 2a squared. Look at this. 7a times 2a squared. 7 times 2 is 14. a times a squared is a cubed. So this is a third way that you can look at this to be able to come up with your common monomial factor. Well, you've gotten your common monomial factor, and then the factored form of your polynomial. This is a polynomial, even though it's specifically a binomial because it has two terms. It's technically, you can refer to it as a polynomial. Now, 21a. What is the common monomial factor? It's 7a. What factor do we have remaining? We have a positive 3. What did we get the right answer? Distribute and check. 7 times 2 is 14. a times a squared is a cubed. 7a times a positive 3. 21a. Which of course is what we began with. So factoring, we've demonstrated, is applying the distributive property in reverse. Let's look at one more example here. We want to factor xa squared plus xy minus x. xa squared plus xy minus x. xa squared plus xy minus x. What is our common monomial factor? Well, there's just not a whole lot going on here. Common monomial factor is x. X goes on the outside of the parentheses. The remaining factors in each term go inside. X times what is xa squared? Or what factors do we have remaining? We have an a squared. We can think xy divided by x. We have a positive x. Now, we have a factor of x and a factor of x. Does that mean we're finished here? No. This is a trap that kids will fall into sometimes. They think, okay, we have a factor of x, we've removed that factor of x, it goes away. Remember, whenever you can't see that coefficient at the beginning, you still have an understood coefficient of 1. So your answer here is actually going to be x times the quantity a squared plus x minus 1. And if you will always take, what did I do with my thing? If you will always take the time to apply the distributive property back, you will be able to automatically verify that you've made the right factoring. X times a squared is x a squared. That's supposed to be a y, not an x. X times y is plus xy. X times a negative 1 is a negative x. So we verify that we factored this correctly. Let's say that you were in a hurry and you simply made that mistake we referred to a moment ago, and you said x times a squared plus y. And you didn't take the time to do your distribution. You wouldn't catch yourself, because look how easy it is to catch your mistake. X times a squared is xa squared plus x times y is xy, and you don't have anything else to multiply, and you look here and you say, oh, I forgot. I need to put that negative 1 in there. So there's a lot of value in taking the few moments to go back and verify your work. So that right there concludes section 9.1, where we are factoring common monomials. If you run into difficulties, shoot me a text, and I'll see you next time.